That's okay. That's okay, I think. So, good afternoon. This is the Federica session in the afternoon. We're going to have two sessions dedicated to the results of the Federica project. Hopefully you heard about the Federica during the plenary this morning. The Federica was also mentioned as a use case during the previous session, and now we have these two dedicated sessions. Our first speaker is Mauro Campanella from GAR, Italy, who is the project coordinator of Federica.
Okay, good morning to everyone. I'm a little bit late, but I was virtually here anyway. So I'm pleased to introduce you to Federica. I will try mainly to describe the status of the project, the achievements, but mainly the idea which are behind these projects and why they are interesting apparently to quite a lot of people. What is Federica? European project, you know it. It's an integrated project, an IP project. 2 years and a half of duration from 1st of January 2008 to 30th of June of 2010. Being a coordinator, too many partners. Half of the partners are national research and education networks because they contribute to the project with their infrastructure essentially. And research centers, Juniper itself, small enterprise, Martel, universities, and so on. So we try to have the right mix of infrastructure providers, researchers, vendors providers. I try to condense the Federica vision, essentially. So when we started this project, we started saying we need an infrastructure for future research, future internet, research in current internet for the development of current internet. How can we do it? Which is the best way to provide a general purpose infrastructure for that? The idea is that if we create this infrastructure and we couple the virtualization capabilities of various hardware, then we can provide probably something which is flexible enough to be used by more than one type of researcher. How? The first fundamental requirement is that if you are serious about testing future ideas, then you probably want to disrupt what you're testing on. You want to see the limits of your network, of your infrastructure, of your ideas. So these facilities should allow complete control to the user up to almost all the size of the layers of the experiment. So the larger the amount of the control you might have on the equipment, on the resources, the better it is for you. You have more responsibility, but at the same time you can test at the same time more complex environments. So this is why facility, virtualization, complete control, and then all communication layers, so try to have all layers available to the user. And then since we want to optimize the use of the infrastructure, we want to use virtualization to create out of a physical infrastructure slices which appear as infrastructures. A particular care we discussed in the beginning should have been given to the reproducibility of experiments. The reproducibility means that being you a researcher, you want to probably do the same type of experiment many times. But then every time the experiments, provided you don't change anything, should provide you the same results. And so this is what we call reproducibility. Last but not least, how we can do it without spending a lot of money. The idea is, can we use what we have now at hand in the national research environment, in the labs, to build such an infrastructure? Well, obviously the answer is yes, otherwise I would not be here. And the idea is that we have in Europe an unknown to many, but very rich infrastructures made out of GEANT and DNRN networking environments. These include GEANT, but includes also the network in Italy, GAR, the network in Greece, GRNet, the network in Switch, which is Switch, and so on. And all these networks actually cover very finely all the research institutions in Europe. So, first thing, start using this infrastructure. And that infrastructure, Europe-wide, can provide you the basic resource in communication, which are links, circuits. The blue lines there. So you have the links all over Europe. Then you want to have something more. You want to have the ability to create new environments from these infrastructures, so you add computers elements. Computing elements in the form of either of switch routers, either in the form of standard computers, with an additional functionality, which is I will be able to virtualize what I do. Once you have these physical infrastructure there, which you have to have, then you can create a slice. You can see those vertical planes there, meaning that out of the physical infrastructure you can take resources, virtual resources, and create new infrastructures. The vision is that these new infrastructure slices will behave like they were real. Where are we? Well, we are almost completed the physical implementation of the infrastructure. Green is good, red is not so good yet. Probably in the next months, essentially, all these links and POPs will be active. There is a major difference between the POPs. We have what is in yellow in the right-hand side of the picture is the core, what we can say a core. It has a slightly more powerful router switches and computers. And the other POPs have a slightly less powerful, but all the POPs have exactly the same capabilities in terms of what is virtualization, both in the network and in the computing environment. Why is so complex? Because actually meshing will help us in distributing better these slices on the physical infrastructure. And the user may also ask a physical meshing for some reasons. So the high number of links, remember these are European-wide links at 1 gig. So it's a quite precious resources that the NRN decided to contribute to the project for free. Otherwise it would not be possible to have such a large expenses, are meshed exactly to provide this richness in the infrastructure. This is a different way of looking where are we. We started in January 2008. The gray area layers are what I would call the substrate, the physical infrastructure. So we are constantly developing the physical infrastructure. What this picture tells you, apart from the red line, which is now in time, the upper layers is what a slice is. So we have a physical infrastructure which has circuits, which has link layers, which has other characteristics, other layers, but then on top, between the lower layers, gray layers, and the upper layers, you have the virtualization capabilities. That will allow us to create, again, a complete new set of layers, starting from the physical data link, network, transport, and application layer. We are starting now. So we will not allow the user in the beginning to access the physical layer. This is still it's quite difficult to virtualize a cable, you know. It's not so easy. We have wave division multiplexing, but that's not exactly virtualization. So at least in the beginning, we will provide complete control to the user, to the application, to the transport, to the network layer, so you can test IPv8 if you want, you can test whatever, or you can get rid of IP if you want, up to the data link layer. For now, the data link layer is Ethernet, raw Ethernet. So no fixed protocol inside the Ethernet frame, so you can choose to have whatever you want. At the end of the project, we might have a possibility to offer to the user also access to the lower layers, data link, and maybe a fiber, according to the requirements. which will come from you, essentially. So what's the process? I need to move there, and I hope that I will shout. Yeah. The process is that we have a physical infrastructure made out of physical... made out of... oh, sorry. Made out of physical elements. So we have PCs, we have switch routers. I will show you which brands and what are they. Connected by physical links. Fine. This is what we manage, the NOC manages. Then we use the virtualization capabilities and we start creating logical or virtual resources. So we are moving from something which is familiar. Everyone is familiar with a physical PC. And probably every one of you is now familiar with a virtual Windows running on a Linux machine, for example. So this is a virtual something which appears like a complete image or a complete PC. Linux box running on top of something. This something is VMware, essentially. So this layer is VMware for what the computers are concerned. So we start assembling virtual resources. Then we connect them together according to the user specification. It's not us that decide the topology. It's the users that proposes us a certain topology. And we distribute that topology on the physical layer. But the user looks what looks like a logical topology. Actually, we start from, let's say, clean resources, and then we move to a instantiation of those resources, meaning assigning IP addresses, assigning a specific operating system, assigning a specific capabilities to these. At that point, the researcher kicks in. When we really start to configure the resources, the researcher is in full control of everything. He may ask for a fully configured IP network if he's interested in an application and not in their network. Or you can just say, I need a raw router because I want to test a new routing protocol. And then he does his own test. This is how logically it works. Physically, what's the substrate? Note that in principle, the user will not touch the substrate, will not see it. Why I'm telling that to you? Because you're engineers and you like this type of hardware, so this is to capture your attention. But at the same time, also because I think that you might be interested in replicating some of these ideas in your own labs. So the hardware is Juniper router switches. There are some SAN machines, some PCs with a lot of memory, a lot of CPU, a lot of network interfaces. Why this? Because virtualization on the network interface is still an hard problem. You still have the fact that if you use one interface for 10 running virtual machines, it's a bottleneck. You can't do nothing. Only now there is from Intel and from other vendors the possibility to have separate hardware queues in the network interface and then assign a queue to each virtual image. But virtualization is not there yet at that level. So what was our approach? A brute force approach. One is not good enough. Let's put as much as possible. So this is an example on where virtualization is still not perfect, or you can't really simulate something, but then you need to complement it using hardware resources. This network, this is just the core nodes, then there are all the other POPs. The core nodes, as I told you, are these Juniper large box with an Ethernet interfaces and these SAN machines. Oops. Okay. So in practice, what we are doing is that we are creating a substrate with physical hardware to create slices, but that means that we are creating what is, well, a small network all around Europe, including a public AS number, including IP addresses, and so on, because we want to manage that. So what we did is an AS on Europe. It's a very large thing. It's equivalent to a small national research and education network, or is similar to what you have in a large university on the scale of Europe. Why we decided to go public? I hate NATs, I hate private addressing for a good reasons. Because if you're serious in testing your own technology, sooner or later you need to connect to internet and test also on the real world. And so the possibility from the start to test also your equipment on internet through different technologies is fundamental. The other fundamental point is that we wanted to decouple the physical location of a testbed from where you are. You don't need to walk to one of these POPs to work on this. You can be everywhere. You can just connect to internet, and through the standard protocols, you will be allowed to access your slides. I will show you how. So, we have the substrate. You will never see the substrate. You will just send a mail to us and say, I would like to have this infrastructure, so please create it. So after some discussion, I will tell you why. We agree. For in this case, a new BGP version you want to test. We create a slice. A slice is a virtual environment, so I just depicted that as a blank slate. We have to create for you a way to enter your slice. So we have some kind of a gateway between general internet and the slice itself. What's this? Obviously a virtual image of a computer. Through that virtual image, the step after that is to create resources, the resources you asked us. Virtual routers, virtual machines, virtual links. An important point is that this is a virtual router. Where is it located here? In principle, our wish is that you have no way to decide if we instantiate that router on the Juniper box, calling it a logical router or a logical system or a virtual router, or it is a virtual router on a Linux system, operating system with Quagga, running on the Sun machines. Because this is the difference between physical resource and virtual resources. It's a functionality that matters rather than how it's implemented. Obviously, the CLI, the common language interface from Juniper is different from what you might have in Quagga, so you might be able to see, it's running on a Juniper. But that's not the point. The point is that we are trying to understand if this environment is good for you and is good for testing. And these parts are part of the game, in the sense that we are really interested in understanding these kind of things. We can't just create one slice. We will create more than one slice running at the same time. So, what is the interference between these two slides? If you are good enough, none. There will be no interference. There will be no crosstalk. There will be no way for the user running in these slice to understand that there is another slice running. Exactly like when you run two virtual machines on the same physical PC. Unless you force them to communicate, for example, looking at common disks, they ignore one each other. They just share the same physical resources. New routing protocols, distributed application, inter-domain services. Yes, because in principle, a user can even request two slices at the same time and then test inter-domain protocols. We had a review, and the reviewers asked us, please try to clarify what's the difference between Federica and other similar initiatives or projects. So I tried to sketch a first draft table of the differences between three initiatives of this type. Probably you may know Planet Lab or One Lab, which is the equivalent in Europe. Planet Lab has a fixed operating system. You can't change the operating system. Emulab is usually referred to as a very nice way to emulate things. Well, once for all, I won't comment every single row, but if you emulate, what you get out is only as good as the quality of the software you programmed. I mean, emulating reality is a very difficult thing. And so you have always to keep in mind that, yes, you can emulate almost everything, but how good is it? Will you really trust? The only way to trust what the emulation does is that after that, you check with reality. You do the same experiment in a real environment. At that point, you can say, yes, my emulation closely represents reality. Okay, so Emulab, well, in principle, it's a fixed environment, although in principle, you can emulate an operating system, but this has never been done. It's too complex. Federica, we can host almost any operating system. Not Macintosh. I'm very sad about that, because Apple won't let us to do it. But apart from this, any Linux, Windows, or BSD can be there. In principle, provided you are compatible with the API specification of VMware, we can host your own operating system if you're really interested to. So, operating system, we have more freedom. Control of lower layers, it's none in OneLab or in PlanetLab because they are running on general internet. They can't control the lower layers. We can provide some. IP, well, yes, it's mandatory in OneLab. It's used to connect to Emulab, and in principle, then you can emulate a non-IP network, and we can do the same. Physical delay and capacity choice. This is how do we really mix with reality? Well, the question is, no, you can't really emulate physical delay and reality in OneLab because you're on top of internet, but you don't control. You have no way of understanding what's happening. There is emulation here. And we have a good possibility to mix reality and virtualization to offer you capabilities. Reproducibility, we try to. User access limits, well, the OneLab and PlanetLab size is quite large now, a few hundred nodes, a few thousand nodes in total. It's an emulation here, so you can go to 1 million, provided you have enough computing time. Well, for what concerns us, as you have seen, we don't have many physical resources for a good reasons, because we want to ensure reproducibility. This is also the reason that brought us to the decision to discuss with users to ensure this reproducibility and not to have a free access at any time to the infrastructure, but rather to have a user policy board discussing with users and then creating the slices. Cost is, well, limited, none. Scalability, medium scalability, well, I don't know what to put here. Let's say reasonable scalability, large scalability. We have a limited scalability according to the user requirements. Of course, I can instantiate 10 virtual computing systems on one SUN, but then there is a sharing of resources. It's up to what the user really wants. So the user policy boards is the key element between the user and ourselves. It's the first contact point for users interested in using Federica. It tries to clarify with the users this strange environment and why we need some documents. One of the documents we want the user to sign is an acceptable user policy. One of the issues that is now rising in PlanetLab is misuse of the resources. I'm an optimist, and I am sure that you have good faith and you won't misuse the resources. But it can be done, and it has been done. So we want at least to have the equivalent of a handshake between the project and yourself to say, no, I will not misuse these resources. Misuse means illegal purposes, okay? It's not a scientific decision, okay? Receive the official request. Then we review the request. But the review is not a scientific review. This is very important. We don't want to judge the value of your work. We want just to discuss with you if it is possible for us to implement it technically, if we will be able to satisfy your technical requirements. Then, once this first step is done, we will implement and we will follow your lifetime, during the lifetime of your project in the infrastructures, and then receive some feedback. For us, the feedback is very important. We start to have some users. We have some collaboration with one lab and some users in one lab to really understand how and well one lab can sit on top of Federica. I have a slide just after that. Open flow tests for those who are not who is not familiar with open flow is essentially a decoupling of the switching matrix to the routing matrix in a router. So the router is just doing switching of the packets, but the decision on where to switch and how to switch is done outside in a PC, which is a quite successful initiative led by Stanford. It was an idea by Stanford. Monitoring, Phosphorus project, and so on. There are various pending requests. I don't have time to go through them. The last slides, so I think I have only 2-3 minutes, right? So 5 minutes? Oh, okay. The last slides, I have only 5 slides more. One of the key issues of these facilities for the future, especially virtual facilities, is, can I connect to a similar initiative, and how? Well, federating, the general term is federating, but federating we have to try to understand what it really means. It might have different meanings. For example, we just want to integrate all the facilities together. Integrating two facilities means that we have a single control plane. So we are, in reality, a single environment, very complex, partially integrated. We can exchange control commands, but each facility will maintain a certain degree of independency. Just overlay. Each facility uses the other, but they do not really integrate. They just exchange services. It's like web services. You can point to another web services, but you're not federating with that web server. You're just using some of the services or the offers of that one. All these way of understanding a federation have various challenges. I will elaborate briefly on that. So, what are the control planes of Federica? The substrate has a physical layer, data link, network layer, and if you want, is plain internet. So Federica by itself in the substrate is now managed as an IPv4, IPv6 public AS with virtualization software inside. This is what we'll do when we create a slice. We'll duplicate, if you want, the layers. So it's layers on layers, but this is actually what the user wants to have. The user now does not really have access to fiber and copper because these resources are precious, and we need to understand if you really had such a low level of access to resources. But the rest, anything. So in principle, we are creating infrastructures over infrastructures, existing ones. Just, okay, let's call it food for thought, although we just finished our main courses. Having a common control plane is very difficult. So this is our opinion initially. But we need to, in any case, to produce resource representation schemas. So if you are serious in developing this kind of approach for providers, for the public environment, then you need to describe the service. And if you need to describe the service, you need to describe what a virtual machine is. And then you have also to elaborate on the inter-facility control plane, how to exchange commands. This is what for example, we can call a federation with one lab. One lab is, as I told you, fixed operating system on some machines connected using general internet. But if we create a slice, we put 2 of those one lab machines and maybe a one lab router, whatever it is, then we actually increase the functionalities available in one lab, allowing them to access also some part of the lower layers. That can be quite of interest to people already experienced it in one lab, which want to also fiddle with the network and maybe fiddle with a router. My conclusions for discussion, if you want, or questions, is that apparently an infrastructure based on virtualization, network, and computing resources can be very useful. Can be very useful to innovation, research, for future internet, for current internet, and most of all, it will represent a flexible environment in which to experiment different type of projects. The engineering of these substrate of the physical resources has to take into account the limitation of the current development in hardware. For example, many Ethernet interfaces or large meshing, because the reality should be there to allow the best testing environment to the user, and in particular, the quality of the virtualization itself. Federation is of utmost importance, but we have to be very careful on how we federate initially, without striving for the highest type of federation, but possibly starting with supporting of pre-federation testing. Thanks.
Thank you very much, Mauro. Questions? Any questions to Mauro? About Federica, about the project? Yeah, one question there.
I will use this one.
So, I got the first one. and the usual, or I guess a question that you can ask coming from me. Hi, I'm Susanna West. I'll be talking to you shortly. What about the offerings of this infrastructure after June 2010? What will be the legacy? What will be how to access this infrastructure after that?
Yeah. Oops.
It's a Spanish one.
Yeah, but the problem is how to. Yeah, N works. Okay. Okay. Okay, almost there. No. Okay. No, it's a good question. This is the usual problem in all European projects. The fact that we built Federica on the giant NRN's infrastructure in some way provides more than half of the reply, in the sense that those infrastructures will be there. And this environment is of interest to the NRNs themselves. So the basic and most precious resources for what Federica is concerned will stay there. At the same time, apart from a possible new generation of Federica, I think it's becoming clear that for the NRNs is also very important, in the sense that for the researchers that access the NRNs, this type of infrastructure might be very important. And so I can't but say that I'm very confident that there will be a constant upgrade and maintenance of this interface, also of this infrastructure, also after June 2010.
Thank you for the good explanation about the Federica project. My question is, how do you see the relation between Federica and the GN3 network and the GN3 JR1 program, where there is a very heavy federated architecture component?
Actually, in the description of work of GN3, which is not really available now to everyone, there are two activities related, one to virtualization and another one related to what I call network factory, in the sense that we have to acknowledge that GANT is not just a network, it's an infrastructure. And the same applies to all the NRNs involved. So in my opinion, there is a good match in the sense that Federica is already built on GEANT, but GEANT also builds things like the network for the radio telescopes, the network for large supercomputers. So actually for me, the issue is, rather than does it fit, is how to manage all these environments on a one physical infrastructure. This is the real challenge. And especially if we are going to a multi-domain environment in the real sense. Federica is already multi-domain because it spans multiple domains and it ends in the NRN's POP. If we want to extend that, the issue, rather than being a physical issue, is a management issue. And this is where the joint research activity in Federica and in GEANT will work.
One last question, and we are running out of time.
Okay, two questions.
Two questions.
I'm still the coordinator, so I can ask for 1%.
Mauro will be around anyway. So
Yes, please. I will be away here until Tuesday.
Thank you.
Thursday.
I wanted to ask how welcome are small researchers? You brought an example of trying out new PGP versions. So internal small tests, how welcome?
Yeah. The only priority we have, which is dictated also by the European Commission, in the sense that first we should give some priority to European projects and European researchers, first thing. Second thing is that the UPB will discuss with these small groups in the sense that I expect that you will come to Federica only after you have tested, at least for some months, the protocols in your own labs. Because this is an expensive resource. And so we are trying to distribute the resources in the best way possible and in the most profitable way for the users. So I expect that the user comes to us with something that says, I tested these protocols, I did some of my own work, and this is how I think Federica can help me. So this is the type of interaction I would love to have with users.
So one last question there.
Mauro, I don't have much direct contact with OneLab, but I understand it's based on Planet Lab. And the Planet Lab people in the United States have done an extension which goes below layer 3. It's called Vini. I don't know whether you have any. I mean, you made a very nice comparison between the resources available in these different things. Have you got the same comparison with Vini? Because it seems to address some of the concerns you have here.
Yeah, I can provide an answer which is the current state. I discussed it with Andy Bavier, which is the responsible of Vini. Vini was actually a natural-born son of Planet Lab, but they tweaked the operating system and the hardware in a specific way. So they too are bound now to a specific environment in the operating system. They are starting to receive from Internet 2 some links, but the main issue for me is that they are not really virtualizing the main computing element. They are still using their own, and this is, I would not call it a bug, it is a feature of Vini, which in some way restricts a little bit what the user can do. So I think that I discussed it with Dan Bavier, and there are good possibilities to collaborate. What I see here is that we provide a little bit more degrees of freedom in the choice of the elements. My preferred image is that Federica is actually a box full of Lego bricks. It's up to you to build what you want and also to choose the color of the bricks. Whereas for other projects is more difficult. And that's it.
Thank you very much. Okay, so the next talk is about the configuration and the management of the slices in Federica, and the speaker is Alejandro Berna from I2CAT. So please, Alejandro.
Okay, do it.
Hi. I'm going to explain how we are enhancing Manticore tool in order to manage virtual machine and IP slices in Federica project. First of all, I will give an overview of the infrastructure and the devices more deeply than Mauro did. Then I'm going to justify why we are going to develop a software tool to manage all these resources. Next, I'm going to explain what is Manticore tool and which enhancement we are developing. And final, I give some examples of the tool we have. As Mauro showed before, we have this infrastructure with 4 core POPs surrounded by 9 edge nodes. The different devices that we have in this infrastructure are switches, routers, and servers. And the idea here is that we have a really flexible network that permits to configure really complex slices. For example, we can perform a live path from Madrid to Berlin, passing through maybe 4 or 5 countries if we want. The first device I'm going to explain is the switches. We are going to use Juniper EX3200, and the way we are going to virtualize is with the VLAN concept. The VLAN permits the isolation of the ports of the switch, but it doesn't permit to create independent management domains. But for the purposes for Federica, it's enough if we can isolate one port from the other, because then we can create one virtual LAN and isolate from the others. Specifically, we will use 802.1q protocol to manage the VLANs. Next, the router, well, we call them router switch because they can behave as a switch and as a router. We are going to use Juniper MX boxes. And to virtualize the routers, we are going to use the logical router concept. This concept replicates all the functionalities that the hardware offers in every logical instance. That means that we can create independent logical domains. For example, if we create a logical router, we will have one routing table for this logical instance, and all the routing domains will be replicated also. Specifically, the technique we will use is developed by Juniper Networks. Finally, the third device we are going to virtualize is the server. We are going to use Sun Server X2200, and the way to virtualize these servers will be with the hypervisor. The hypervisor permits running different operating systems in the same machine at the same time. Also, the good advantage that it has is that it virtualizes the whole hardware. For example, a virtual machine instance will have virtual RAM, virtual disk, virtual interfaces, and all the hardware virtualized. There are 2 kinds of hypervisors. We have the native, which runs directly on the hardware of the server as an operating system, and we have the hosted, which runs over the operating system. Specifically, for Federica, we'll use the native hypervisor VMware ESXi. We did a small comparison with the most used tools for virtualization of servers, and we decided VMware because for developing purpose, it's really rich with documentation and examples, and it has less limitations of network interfaces than the other tools. Finally, as Mauro pointed, we are going to use also software routers. A software router will be a virtual machine with a Linux installed, and over this Linux, in the first release, we have chosen Shorp tool, and this tool will permit this virtual machine to behave as a router. We choose Shorp because it's open source, it supports a lot of protocols, and it has a command line interface to be managed, which is really simple. The reason why we are using software routers in Federica, the first one is because we need to provide an open source solution for the researchers in order if they want to test a new protocol, they need to have the tool to do it. And Shorp has a really modular architecture, and if you want to test a new protocol, you only need to create a new daemon, and it will run. Also, the other reason is that we only have 4 switch routers at the first release, so we are really limited on the logical router instances because we can only create 64 logical routers. Then, with the solution of software routers, it is possible to create are really complex slices, a lot of virtual machines behaving as software routers, then we can create more slices and more complex. We also did a comparison table to select the routing tool. We also compared the most famous and used tools, and we decided Shore because it was the one who supports more protocols, and also because it has this modular architecture and permits easily to test new protocols. Why we are going to use a software solution to manage this? Well, the first reason, it's obviously, imagine in every core POP we have at least one switch router and 2 SAN servers. And also in the non-core POPs we have at least one switch and one router. So if we multiplicate everything, what we have is 30 devices to be managed. So this is a really big amount of devices. So imagine a possible scenario could be for the NOC, 10 VLANs in every switch, 16 logical routers in the physical routers, 20 virtual machines behaving as normal computers, and 12 software routers, virtual machines behaving as software routers. That means 6098 virtual devices to be managed by the NOC. This is a really big amount of devices to be managed. Also, the other reason to use a tool to manage all these devices is because every device has its own interface to be managed. For example, software routers use command line interface. For VMware, what we have is the VMware infrastructure client. For physical routers, we have the command line interface of UNOS, and also for switches, the same interface. That means that we have 4 different interfaces to manage the 4 kinds of devices that we are going to use in Federica. That means, for example, that a possible scenario for the end user, it's 4 show routers with 6 logical routers and 3 virtual machines. That means 13 different tool instances opened to manage his slice. And also for the NOC scenario, as we told, we have 30 devices, so we have 30 tool instances opened. Also, we have to point that it is necessary to control all the slices we have, which devices has these slices, and also who has these slices, who is controlling them. This is a really big amount of information that is needed to manage. Then the NOC can become crazy. What we need is a really reliable database which manages all the information necessary for the project. Also, we need a tool that merges all the different devices that we have and a tool that permits to manage only with one tool all the devices. And also, we need a graphical interface which makes easy this management. Now I'm going to introduce a little bit Manticore. We have to point the second point. Manticore allows infrastructure owners to manage their physical infrastructure, creating virtual slices and enabling infrastructure and users to control them. That means that we have a NOC admin who has an infrastructure. He can create independent slices of this infrastructure, and he can sublease the control of this slice to researchers or end users. This is what Manticore offers. Then the Federica use case could be the infrastructure owner will be the Federica NOC, the infrastructure end user will be the researchers, and the virtual slices, the isolated slices that we will create in Federica. Also, Manticore offers an intuitive graphical interface to manage all the devices. The current release of Manticore, that is our starting point, permits the NOC admin to manage all the physical routers. That means that he can create logical interfaces, configuring VLANs in the interfaces, and also he can create logical routers instance. Also, Manticore current release permits to the end user to manage his own IP slice. That means that he can set static IP and routes, and also he can configure OSPF and BGP in his own IP slice. As we can see, Manticore also has a really modular architecture. What we have in the low level, we have the devices. In this first release, what we have is Juniper devices. Then we have the netconf driver that permits to manage and to speak with this device. Over it, we have the router web service, which is every router web service instance represents one physical router. This router web service is the one who has to speak with the router and to perform all the configurations requested by the user. Over this router web service, we have the IP network web service, which represents one IP slice. For every end user which has one IP slice, it will be one instance of IP network web service. And finally, we have the graphical interface, which is working as the client for the web services, and it's really easy to manage all the devices with some views. We will see in the final of the presentation. To enhance this tool in order to fit in Federica requirements, the first thing is to manage the hypervisors which virtualize the hardware of the servers. What we need to do is to manage all the virtual hardware that we can create, and also to permit the creation of virtual machines and to manage them. To communicate with VMware, what we will use is the VAPI, which is a web service-based interface and has an oriented object architecture. The first thing that we have done in order to create this new service for the final tool for Federica is a data structure that represents this server. This data structure, as we can see in the top, we have the server. From the server, we have the physical interfaces and the physical hard disk. And then we have the pool. The pool of resources is the virtual resource pool. Then from the virtual resource pool, we have the virtual machine, which is linked with virtual disk and virtual interfaces. Also, we have port groups and virtual switch, but this is specifically to manage VMware servers. We have done a really modular architecture in order if we have to change solution, for example, or VirtualBox or KVM, we can use this data structure also. The main use cases that we need to implement in order to fit in Federica requirements, the first one is to permit the end user to upload an ISO image with the software he wants to install in a virtual machine instance. Then, for example, we can have this, and the end user creates an ISO image with his operating system and the different tools he wants to install in the virtual machine, and then the NOC receives the request, and he creates a virtual machine with the software of Federica and links this ISO image as the main CD-ROM of this virtual machine. Then the end user can install whatever he wants in the virtual machine he wants. The other needed use case is permitting the copy of virtual machines. Why we need to permit this? If we want to use software routers, the easy way is to have software routers templates, which means really simple virtual machines with the hardware enough to run Linux and Shorp tool. Then we have this software router template stored in every server, and the only thing we need to do when an end user requests a new software router is only to copy this virtual machine and to specify the new hardware requirements that the end user has requested. Also, the other important thing we need to do in order to fit in Federica is to permit the management of software routers. Currently, as I told before, we can add a Juniper router, manage it, and we can set a static IP and routes and configure in OSPF and BGP. So in order to fit software routers in this tool, the first thing is to permit to add the software router to the system and to manage it. Also, it's really important to permit only the sublesion of selected interfaces, because for every software router, we are going to use one interface for management purposes. This is different than with the logical router instance of Juniper, because we are only using one management interface for all the logical instances, because we are managing the physical router, not the logical instances. And finally, we have to create a driver with the new capabilities to set static IPs and routes and configure an OSPF and BGP. The resulted architecture will be the next. As we can see, we have a new router, the software router. We have created the new driver to communicate with the software router. The router web service and the IP network web service have not changed. And also, we have created two new web services. The computer web service, which represents one instance of a server, and the virtual machine resource web service that represents one virtual machine instance. Also, we have created the driver which communicates with the VMware via API. As I told you, here we have some screenshots of this tool. This is what the NOC admin sees as the first time. We have the physical infrastructure view. As we can see, okay. As we can see, we have one physical Juniper router, and we have logical instances of this router, and also we have short instances router. Then, from here, the NOC admin is able to create, for example, a logical router from a physical router with this simple interface. We only the identifier, and we select the logical interfaces that we have previously created. After that step, what the NOC admin has is the resource list. This is another view from the tool. And the resource list is all the virtualized resources that the NOC has created. And from here, he can sublist the control of the resources to the end user. Finally, the end user view is the next. And what he can manage here is the IP slice. What he can perform is modifying IP addresses, configuring OSPF, BGP, and it's also with a simple graphical interface. As we can see, we can modify of a link the two IP addresses of the two peers. We can also configure OSPF, just selecting the interfaces to configure and then specifying the area. And finally, we can create BGP with policies and all this stuff. As we have seen, what we have concluded is that it's possible to create these independent slices, and also we have concluded that it is convenient to have a tool to manage all these slices. We need a database to maintain all the information, and also we have concluded that Manticore tool with some enhancements can be this tool to manage Federica resources. And that's all. Thank you for your attention.
Thank you very much. And questions to Alejandro? Or maybe you are a bit scared about the complexity of this management slices. Okay, thank you very much. Yeah, one question there. Yeah, sorry. Maybe you need the slide.
Now, it's about the web services you have defined are running on top of, I mean, they are SOAP, REST.
They are in a virtual machine inside Federica infrastructure, and they are offered there. This is your question?
No. I mean, it's they are based on SOAP, WSDL, and the typical framework.
We are using Globus Toolkit solution.
The Globus.
Okay, thanks again. Our next speaker is Susanna Westle from, she's the coordinator of the Fireworks project, which is a coordination project on all the future internet research projects in the FIRE initiative. Please, Susanna.
Yeah, so good day to everybody. So Federica doesn't support Mac, but so does also this system here doesn't support Mac files, and I have to rely on PDF, but I think we can survive it. First of all, courtesy of the Commission, this slide explains you a bit what FIRE is. FIRE was lit a bit more than a year ago. The first project started 1st of April 2008, and the FIRE stands for Future Internet Research and Experimentation. So it's a new initiative in a commission to combine experimental research, building facilities, but also having research very tightly connected to the facility building. So it has two dimensions. It has the agenda of supporting and trying to find what are the needs for the research in this area, and also having this validation loop, so to say. So fireworks, that's the project that coordinates this new initiative worth 40 million euros public funding. I think it's something like 58 million in total for 2 years. And now there is a new call opening end of July this year, and it has, I think it's the only initiative in Networks of the Future that increased its budget, so it's 50 million this time. But anyways, Fireworks coordinates all these 14 projects, and it's doing this. It's doing the community building, it's building a kind of sustainable initiative, it's providing office services, but it tries to be the brains as well, not just the secretariat, or just, it's not a just. But anyways, we've been working on a fire strategy. So what research, as I mentioned, but also what type of facilities do we need to support this research? And the question that actually Mauro already answered on behalf of Federica was about this federation. So as fire is about different facilities, different projects building facilities, the elementary question is also how to bring these things together, how to make them sustainable and how to bring them together. So hence the concept of federation. And we've been trying to solve this very, very complex problem, and there will be a proposition for the roadmap of this fire facility. Traditionally, the research in a future internet area is layered. So we think about different layers, and we think about different disciplines. But fire tries to be a kind of a pioneer in changing this idea, I think. It tries to be a forum where you don't need to be sticking with a certain layer or certain layers. You can think free, you can think also, this is more difficult. It's easy to think layer free, but it's difficult to think multidisciplinary. It's difficult to talk the language coming from different disciplines, but this is something that actually future internet needs to overcome, this type of challenge. It needs to be able to open up. Have kind of a system approach. Think about future internet as a system. And this all needs validation, verification, experimentation. And these facilities are not only for, let's say, academic researchers as such. The FIRE also talks to industry quite a bit. We try to be able to cover the experimentation from the very disruptive and clean slate approaches also to pre-commercial validations. And yes, not necessarily backward compatible, but there should be a slot also for this type of things. There are some keywords like bio-inspired principles and so on. But anyways, also this experimental issue has been taken more widely if you think about the Commission way of looking things, and unfortunately I think it has given a kind of a tattoo on me also in the past 2 years, that I tend to also think how they think or how the structure thinks over there. But nevertheless, there is this whole umbrella of future internet called, or constituency for future internet research called Future Internet Assembly. And I think this whole 500 people's constituency is starting to think more and more like FIRE. So how this experiment should be put into action. I think for all of you also, this is not something to be taught, but for some people it is that it's not just paperwork, or it's not just a small-scale verification, but you actually need big facilities and large-scale experimentation. And the last bullet point that actually I added, this is not anymore Commission slide in that sense, is the people. So how you take into account the people. Okay, researchers as such, but also how about those people who actually use the internet and interface it. So this was my fancy animation. Never mind that. Never mind that. That actually tries to tell you different domains that the FIRE project for the moment cover. and also somehow map different projects on top of that. The blue balls are facilities, so OL2 stands for One Lab 2. Then there is P and Roman 2, that means Pan Lab 2. And then there's Vital++. And actually, WISEPET you cannot see, it's over there, it's about sensor network. And the other beige balls, they are more concentrating on different areas of research. They do have experimentation element, but they are more research-oriented projects. So this is the landscape of a FIRE for the moment. This is a little bit how it started. So in FP6, framework program number 6, we had this One Lab, Pan Lab, and different projects. And now we are in the middle column here, FP7, and all those things are now put there. You see there is also Federica. It's kind of coming in, so to say. So we are already considering Federica as part of a FIRE project because it provides such a elementary facilities. And then the future is over there. So we would like to expand more to the service architectures and perhaps computing, cloud computing, enable socioeconomic better than what it's for the moment as a mandatory work package in every project. And yes, develop and also go global a little bit more. So this has been making me gray for the last year. How to build a FIRE facility? It is really not a trivial thing, and the pressure is very strong. As you may understand, that the ambition is to build one facility, one-stop shop, so that research and the developers in Europe could use the same interface and access resources agnostic to the technology. This is the ambition. But how to implement this is not so easy. First of all, because we are talking about short-term projects, which should be sustainable to some way. Second of all, because they are very, very heterogeneous. They are tackling different customer groups and different layers and so on. And of course, we all have our egos, so we don't want to go under the other guy's rule, basically. So this is the thing. So we've been trying to identify the scope. We've been trying to identify who might be the common users of the different facilities, how much there will be. That would have been my answer to you also, that okay, you have 600 devices to manage, but what is the usage rate? How much your resources are actually in use for the moment, and how much you want them to be in use? This is also a question in my IP projects, is that they are perhaps not yet mature to be totally open to all customers, all researchers, but at one point they should be. And how tightly we need to be together. So is it a common umbrella or is it a common architecture? More, again, what Maura was talking about, is it interconnected, partly interconnected, or is it just loosely coupled, so to say? That was kind of an illustration of what we have today. We had a FIRE expert group that was sketching this type of a Venn diagram and trying to categorize in two axles, physical extent and also the speed, different projects. So Federica, to this, is neutral, so to say, to the physical extent in terms of broad or narrow, but it's quite bandwidth is very, very high. And on the other hand, okay, One Lab 2 covers a huge amount of map, maybe due to the first drawer of a big picture who comes from a One Lab 2. No, honestly, I think they cover a lot. But anyway, so this is what we have today, and this is the basis where we would like to identify the gaps where to grow in the future. So, I'm talking again about the federation. There are nice definitions about federation, like that it's a union comprising a number of partially self-governing regions united by a central government under a common set of objectives. It needs to have common set of objectives. And multilateral benefits, so we don't want to federate for the sake of federation. We need to have a reason for that, and we both need to have a reason for that. But yet, if we decide to federate, it means that we need to compromise something. We need to go, and to be seen as a single resource, we need to have a common government. I think I actually mentioned most of this also earlier, but this actually dates, this vision for fire facility dates back quite a few, 2 years ago, when we had a workshop and brainstorming session about these type of things, and especially industrial points were brought up. So this fire facility would like to be seen. I believe there are people who have different opinions of that, but of course, subjectively speaking, we would like to see fire facility in the core of a European and global testing market. It means also industrial aspect. It should be a high-quality test center, very, very trustworthy, of course, and a part of all European R&D. As we say, the experimentation should be in the core of all the research of the future network. It should evolve to become a standardization point, because I think many people already today think that the standardization always comes like lags behind. It's something is already done and then they standardize it. Maybe in the future, this type of a common facilities could become a dynamic standardization place. People come together anyways, or they test it openly, and that becomes a standard. Incubator of new innovations, yet to be seen, but that's what also this kind of a facility could provide. But yet, this is, I think, even though it's the last bullet point, I think this is very, very important, that the autonomy of resource providers should be ensured. So even though we would federate, go together, it should be ensured that people can sustain and they decide are they part of it or not, and how much they allocate resources. So now I go a little bit to the detail, into more detail of OneLab 2, which was mentioned many times earlier. So these slides I've got from coordinator University Pierre-Marie Curie in Paris, and these three guys, Serge Frida, Panayotis Antoniadis, and Timur Friedman. Nice vision, isn't it? The globe all together. And Europe is nicely big, you know, having little balloons, but the huge balloon in the middle of it. Okay, so from their point, custom-made view and experimentation. So what do I want to achieve? I want to test a proposition on some of these ideas, but I would have these lower objectives that I need to meet. I need to be able to decide on the openness of my results. I need to, on the other hand, understand the IPR issues. How do I integrate, and what's my scale? This is different aspects on experimentation. And the facility then is a means to come to this. But is it a collection of test beds? Is it a collection of federations of test beds? Or is it a single test bed? What does it make? What's useful for me? Or is it merely a toolkit? Is it a toolkit to support what I want to do? Can I use it really like the box of Legos that I myself build what I want? So PLE, Planet Lab Europe, was built during OneLab 1. OneLab 1 project finished last September, and they established a European-centered or managed own federation of Planet Lab nodes. And I think nowadays there are something like 200 nodes. But they are federated to the Planet Lab Central in Princeton. So basically the whole global network is achievable. And it's the same as Federica. It started something that already existed, so it didn't start from zero. That's what we see as a federation vision. So basically you share the credentials and you agree on the policies, and that's it, you run it. You get the slices and you do it. But it gets trickier when you add diversity. When you have homogeneous resources, that's as simple as such. But when you start putting different testbeds and different federations, you need to go to the hierarchical federation. And here you have global, but also different other elements. So PLE Europe, PLC in Princeton, and PLJ, actually core lab nowadays in Japan. And then you see Vini, Orbit, Emulab, and so on. So currently, federation policy is peering. So you have same rights if you access in your own federation. But if you think about the further the distance goes, you might understand that in terms of the IP, it makes sense that maybe you have to have different policies. And this is, on the OneLab point of view, the federation with Federica. They see PLE users as a subset of Federica users, the same as Mauro was mentioning. But in addition to this aspect that OneLab could bring their customers to Federica, they could also offer, as they create certain tools for the federation, kind of a toolkit. For example, monitoring would be something that they could provide for a wider federation, experimental facility environment. Another slide of different. There is a concept of private Planet Lab, which means that in its purity, Planet Lab is totally open. You get you give 2 nodes and you get 10 slices in return. So you don't give something to the federation and then you get the resources. And it's all open. You have to announce what test you run and then you just run it. But there is also a concept of a private Planet Lab, which means that you can create your own little Planet Lab with the same resources, but then it's kind of a wallet garden and it's not accessible from outside, and you do what you do with kind of root rights in it. So these are the challenges. Virtualization as such, of course. Monitoring, as I said, that is what we've been really tackling in the project. Legal issues, surely. In the research community, it's not so difficult. Well, it's difficult, but it's totally different scale of difficulty if you go to the industry in the same way. Benchmarking is something what's needed, security for sure, and then economics. Economics from different points of view. So how about these resources, how you share them, or if somebody who doesn't have something to give in the federation, how they should be charged for using the facilities. And then, of course, the federation is, from the different points of view, it's a challenge. So today, in Planet Lab Europe, these are the figures that you have. But in Planet Lab Global, there are something 1,000+ nodes, and it's growing something like 100 nodes per year. Now the wireless is a big thing in a new component, but also this Wi-Fi testbed NITOS as such is another OneLab supported infrastructure. And this is the future, what's coming up. SAC means Situated Autonomous Computing. That's where is Anna and Haggle projects which are getting connected to a OneLab 2. And as mentioned, the wireless is getting in. And then the access to computing clusters. Also, Federica is mentioned here, so I guess it's on both sides kind of mutually agreed that further cooperation is needed. New components, emulation, monitoring, yes. This was the highlight. No, actually no. So to summarize, so FIRE is a concept, so it has two dimensions, the experimentally driven research and the modular building facility, sustainable facility. And then about the One Lab approach, that it's a proven model for federation, research and innovation incubator, and it's existing already, so it's ready to be connected. The black box here is a polar bear, which is very depressed and crawling in the ground because it's doing its things alone. And the penguins are here freaking out because we are so happy together. So that was my thing. Thank you.
Yes, I would like to know if you have any information of the clearinghouse that they do now in the States. I mean, apparently the Gini community has decided to do some changes in what was perceived as a clearinghouse before, and I'm wondering if there is any information on that by you, by anybody else here.
About Gini, I cannot answer. We will meet them 22nd of July and hopefully being able to brief you better about their status after that. Also about the status of what is the European partners' situation in the results of the call 2 that they closed in February. I think there were several European partners also becoming involved in Gini as such. But in terms of FIRE, I think this discussion, I think we've been pretty much in dialogue with Jenny and FIRE and exchanging experiences across the Atlantic, so to say. And this decision, I think decision in Gini also to make it as light as possible, the common control frame, has influenced also Europe or vice versa, I don't know. But in FIRE we had a special task force for discussing and trying to find how would this control plane look like. Is it possible or what should it be? We call this group FIRE Wise Men, and their report will be out 1st of July. But I think the first outcome of this was that it cannot be very heavy, it cannot be forcing to one facility. On the contrary, it needs to respect what is already built up and rather ensure that they grow as they do independently, yet knowing about the existence, so that they don't compete, they don't replicate something that's been already built, but they are ensured to grow as such. So I think this is the status for the moment.
No questions? Thank you very much again. So, the next session after the coffee break is again about Frederica, in more technical directions of Frederica projects. So, coffee break now.